Data isolation. What we are learning now is drawbacks of files. See, definitely we have to go by the background, like why we need this database management system, right? Then only we will understand its importance. When you have problem with some kind of problem you are facing with some particular system, then only we think of something new. Okay, so these traditional file system and database management system, these are the simultaneously you will understand what were the problem with the traditional file system, and that will become the need to evolution of this database management systems. Okay, now isolation, nowadays this term is very popular, isolation. If okay, because suppose one file is storing your student detail, other is storing your library details, other one is storing your marks details. So but those files are not connected. There is no way to link with each other with the data stored in files. So those files, the data which is stored in files is in isolation. There is no relation between those files. For example, if you have to generate a single report of a student who is studying in a particular class, his study reports, his library book details, and hostel information, then you have to go to 4 different files and then fetch that information. Maybe you are simultaneously opening all those files, and the same roll number you are finding in library books also, because your unique ID is going to be uniquely identify you. So 4 different files you are opening, then fetching, identifying, and then you will be able to answer this particular question. Who is the student, what is his library report. So if we are using file system, it is very difficult. Basically we have to write a program. There is no other way. Programmer has to find out with all these files, and then he has to write the program. Writing a program for each simple small thing is very difficult basically. So this is one drawback. Data is stored in isolation, and fetching interrelated data is difficult. Okay, integrity problem. Integrity is overall completeness, accuracy, and consistency of. If you have redundant data, it will lead to inconsistency. But we need consistency in data. Take a very simple example of your account. So you have transferred some money in your account, and if the data is stored at multiple places, then at one place it is showing, suppose earlier my balance was 2000 and I transferred some 500 more. So in one file it is showing 2000, and the other file which got updated is showing 3000. That is inconsistency, that is inaccuracy, that is incompleteness. Okay, so integrity was a problem with this file system, because at different places data is stored and we cannot update. Maybe we try to update, but as the data grows, the management will be very difficult, and at some places definitely we can forget to update. So that is one problem. The data value stored in the database must satisfy certain types of consistency constraint. Okay, here one more example is taken here. For example, we have to restrict the student age above 18 cannot take participate or something. Actually, you have to write programs for that. But in database management system, it is very simple to add constraints. Constraints are, what are constraints? You will come across this term very frequently. Constraints are some rules basically that is to be put in on your data. Like there is a constraint, if you have not completed your BSc degree, you cannot take admission in MSc. So that is a constraint. Okay. Or suppose if you want to apply for a driving license, you should be of age 18. That is a constraint. So whatever rules are there, we call them constraints. Okay, so it's very difficult to implement those rules with this file system. Integrity is a problem with it, which is overcome in this database management system. Atomicity, that is again a very interesting term. Atom is basically a single thing we consider. No? Atomicity has come from it. Atomicity says either your work should be done completely as a single unit, or it should not be done at all. Like if you take an example here, let's go through. Atomicity is the ability to do certain operations as a single unit. That means if an operation happens, it happens in totality. Otherwise, it will not happen at all. The same example you can take, fund transfer. Suppose someone has transferred the fund in your account. So that will be debited from his account, right? The person who has transferred that, the same amount will be debited from the other person account. And suppose it is debited and it is not credited in the other account. So there will be an inconsistency. Once it is transferred, it should be credited in other account. Atomicity says it, the whole thing, like debiting and crediting and updating the database should happen. Otherwise, if there is some problem happen, there are problems, network issue. Suppose you are withdrawing money from ATM, right? You have entered the PIN, you have entered the amount, but suddenly something happened and it may be some network issue or some hardware issue, anything, and it could not complete. The transaction could not complete. Will you accept that and that withdrawal operation was done? So no one will accept unless it is not debited and come to your hand, right? So that is called totality. Either this whole process should happen or it should be rolled back. And it is happening. You know, if some network issue comes, then it goes back to your account, get debited from your account, unless it is not transferred to somewhere. Suppose you are doing online shopping, you have done, selected the products and you are in a process of payment and something happened. It happens many times. So it never happened that it is debited from your account and your order is not placed. This whole thing should happen. Either it should happen in totality or the whole thing should be revert back. So that is one, we can say we have solution in database systems for this particular problem, but in file systems it is difficult. Atomicity is a problem. Atomicity means whatever work, basically a transaction is a set of small operations, we can say. You can consider that withdrawing, debiting and crediting together will make one transaction, right? So if only debited and not credited, that will be inconsistent. So it is saying either it should happen in totality, it should not happen at all. So this is one problem. File system do not guarantee atomicity. If there is any failure to insert, update or delete in file system, there is no mechanism to switch back to the previous state. Basically in database, we have states. At every state is stored. If any change in any data, any updation, any deletion, any insertion will change the state of your database. Suppose right now I have 45 students in my FY class. And as soon as 3 more students took admission, or even one single student took admission, the state will change to 46, right? So in database, we have provision to go back to the previous state. But in file system, it is difficult. So that is a problem with file system. Okay, concurrency access anomaly. Anomaly is one term we will come across very frequently. Anomaly is some type of problem itself. Okay, concurrent means at the same time, more than one person is accessing the same database. And a very simple example we can take when we are doing our reservation. Suppose you are connecting to the IRCTC website. So many people at the same time are logging, accessing to the same database. That is concurrent access. In database management system, that is possible, but in file systems, that is very difficult to handle. Very good example of this booking reservation or online shopping also. You are connected to the same database. Till the time you are putting in cart, it is available, and when you are paying, it is not available. Maybe whatever was the last item available, someone else has already paid it. So that is one thing, one problem basically, which our database management systems give solution to. Then security problem. Secure admin users have special rights. They can access to more privileged data as compared to normal users. So that is this is because of our database systems. But in file system, it's difficult to handle such kind of accesses, like giving some different access. Okay, these are some problems with the traditional file system, which were the basis of database management systems. Database systems offer solution to all the above problems. This is basically a difference you can see here. File system, you can see from bottom, this file system, operating system, then interface through high level language. High level language, all of you know, C, C++ are high level language. Your assembly language is some middle level, and then your binary language is the lower level language. So we are using some language, maybe C, C++, and we are writing the programs, and then we are showing it to user. Here, what is this? We have a database management system. So all this writing of programs, all this complexity basically has covered by this database management system. And we are still using some language, but SQL, that is very simple. You don't need to write long, lengthy programs system. This software is handling all this complexity. It has given us a simple interface, like query language we can use. Okay.